Thank you. That's correct. My name is Hans. I work for Norkart in Oslo, Norway. And as was introduced here, I have 7 years FME experience. Certified training professional, and I spend most of my days at work writing data to or reading data from Norkart's data warehouse, which is basically a collection of databases that's are the base of all the services or web services and data deliveries that we provide to our clients. So this is like the wow statement. Each day we have 8,000 approximately FME server jobs that writes data to or read data from the Norkart's data warehouse, which is, as we heard in the last presentation, the same amount almost as the European, what was it, Environmental Agency? Yeah, well, I think that's impressive. And I figure out after working with the workflows, many of the workflows on these jobs, that monitoring all these jobs is a way harder task than creating the jobs themselves. So you can't really monitor 8,000 jobs manually, so you have to do it automatically. And there are a few simple steps which seems quite obvious here that you need to do. There might be even more because you can never be completely sure that your jobs have been successful, but you can do some tests that can tell you by almost 99%, you can be 99% sure that everything was okay. So we do a few things. The first thing we do is to check the FME server REST API, whether a job was successful or not. Or you can use notification services on FME server, it doesn't really matter. We also do a check that the data source, if the data source has been altered, because we collect data from almost 100 different data providers, most of them public or governmental organization. And they are not always well documented. They can be downloaded through file downloads APIs, or by services. But you never get a warning if those data are altered, and that's the true of many of the data sets. So you actually have to do that job yourself. And if you're sure that the data hasn't been altered, we have to check that the content is reasonable, because those who are managing those data, they can do mistakes. And I have been into situations where we download the data and half of the objects are gone. And if we then build services on the same data, offering them to our clients, we are the ones to blame if the data is not there. So that's not a very good thing to do. Once we get them into our staging environment in the warehouse, we need to refresh materialized views. I'm speaking about Postgres here. Materialized views is an amazing structure in Postgres and Postgis, which is basically a table that is refreshed by executing an SQL script instead of using like the regular table inserts, updates, and delete. Once I have updated my materialized views, I want to check that all my indexes are okay. Sometimes, if data have been altered, I need to recreate some tables and some views, and if you don't get those tables and views properly indexed, you get either really slow maps or really slow searches. So it seems pretty hopeless to the ones that are using your data. So you can use Postgres tables to check if your views are, no, if your indexes are okay. Another thing is that if you have to recreate tables or views, you have to make sure that those who should have access to the data still has access after updates. So we normally store these privileges in separate tables, which we join in. Creating SQL statements, and we use FME all over to create those statements. And finally, after we have done all this, we can be pretty sure that everything is okay. But if we do find errors, we should report them to the data provider so we don't have to deal with the same errors over and over and over again. I just want to show, if I have time. Yeah. This is just a sample workspace where I've, whoops, what's going on here? Yeah, okay. It will probably fire up. I hope. Ah, here it is. Okay. This workspace is just, well, it's not a real test because the real tests are built into more complicated workspaces, but I pulled out the most important things. So first, we check the FME server for status. If my workspace was successful, I push it out here, and I go to the next test, which is a test whether the schema I've changed from my production server to my stage server. I need to make sure that the new data that I downloaded, I keep the same structure, otherwise I need a warning. So each time a test fails, there is an object going to this warning. Yeah, in this case, it's just an inspector. Normally, it's a log file, or I write to a database log that I will store away all the error messages that has occurred from that job. And if it's successful, it goes out the unchanged port. If the schema fails, they go to the added or deleted port, which means something has been taken away or something has been added that will affect the tables that all our developers rely on and that they expect to be unchanged from day to day. After we have checked that the schema is okay, we go to the count objects session. And that's why we need to know that there is still data there. If you had 5,000 objects in the data set one day, you shouldn't have 2,500 there the next normally. So we do a check, and if the difference is 10%, is within 10%, we regard it as okay, but that could be any number. But then we can be pretty sure that there is no critical errors. Then we go to the next step, which is refreshing our materialized views. We use a string concatenator to create a SQL script, which we execute through an SQL executor. And then we have all the materialized views, which is the base of all our services, mostly, updated. And the nice thing about materialized views is that they will not be down while you update them, like regular views will be, because if you empty a table with a data set and you take that data set away completely, it will be down for a few seconds or a few minutes while you insert all the new objects. But a materialized view would still be available while you are refreshing it. So it's a very, very good way to store data in a consistent way. Then we get to the check index check, and that applies if you are recreating any views or any tables. So you can use feature reader to to read data from the PG catalog schema in Postgres. Any of you who haven't tried the PG catalog schema, if you work with Postgres, it's a very, very good way to read tables with a lot of useful information of your database. There are all kinds of indexes. There are triggers, there are tables, there are information about Wacom. It gives you a lot of information about the overall health of your database, and you can do a lot of good things with it. I think there are at least 100 tables or something in there. And I can check that if a table or a view that holds my data set, if that has less than 2 indexes, I should get a warning, because I need a geometry index to make it draw or render fast on a map. And I also need a unique key when it comes to refreshments. CQL to grant access is the last thing we do. We have all the users stored away in a separate table, and we also have the relationship between the data set that each user has privileges to. So we combine these together, and we merged the views with the user access, and we get an SQL statement in the end, which looks something like, well, grant access. Here it is. I don't know if you're able to see it. It's very small up on this screen. But yeah, can you see it? It doesn't really matter. But you use FME to create SQLs that would otherwise be quite difficult to create because you combine data from so many sources and different tables. So it would take a very good programmer to do the same thing. And then you execute it, and then you're up and running. We run these things every day. Everything is automated, so basically all I have to do at work at the moment is to check that I don't get an email with an error message that something is wrong. And also, if something is wrong, there is a flag on the routine that transfers the data from the stage server to the production server, so that will not happen if one of these tests is negative. So that's how we run updating of the Nordcache data warehouse. So using FME as an administrative tool around your databases is very, very handy. But it takes some time setting it up, definitely. But it's a great reward when you have it. Any questions?
Any questions for Hans? One over here.
Yeah. We store them away in a database. We don't really analyze the log files itself. We just read through them. We even write successful jobs to the logs, but we don't get an email warning on what is a success or not. The only log files that we do some analysis on is actually error log files related directly to the data that we can give back to the data providers. We store where the error is. It's normally related to geometry that doesn't fulfill the geometry validator requirements. And then we can send the log file back to the data provider. But apart from that, we don't do anything. We get a warning. We know that the data set is stopped from being updated on the production server. We can go in and see what the problem is, and then we can transfer it to the production. Yes?
Just add to that, if you have a chance, talk to Ryan Crew at the doctor's office. For his Innovation Days project, he explored storing FME log files into Elasticsearch using Logstash, and then he set up patterns that would cause or be able to produce amazing dashboards with that Kibana tool. And all of that is free. So you might find that there might be some value in creating dashboards for almost no effort other than the setup. Because since you don't have any work to do, since all you do is check the anything.
Well, yeah, thank you very much. And that will come in handy because we use Elasticsearch a lot. So, yeah, we're already there.
Yeah.
Or we're close to being there, though.
Yeah.
Thanks.
We have time for another question if anyone has one. Alrighty. Thank you.
Yeah, yeah.
All right, thank you very much.
Go on.